Alright, let's start with this topic. We'll understand what is MANET in this video. Okay, first let us go through this diagram first. Then we'll go through this points. You'll understand in a better manner. Okay, if you can observe in this diagram, we have different nodes which are connected wirelessly and communication between them is being taken place. If you carefully notice, this is not a centralized architecture. There is no network administrator here. The communication is taking place with the nodes itself only. The nodes are acting as a host. The node can even act as a what you call router. In general, what happens in an architecture is that we have a network administrator. We have fixed nodes. Suppose that this is the network administrator. There are fixed nodes here. Okay, the communication between these nodes would takes place through this administrator, or else you can suppose the administrator will guide these nodes. This would be the general architecture. Okay, this one is a centralized architecture, you can tell. MANET is like a wireless architecture. We'll understand this term by term. I think it would be better. Mobile ad hoc network. Mobile is this, not the smartphone or something else. Mobile is mobility. The nodes here can move here and there. A new node can come in. Okay, that node can also move. That is mobility. Then ad hoc is like whenever it is needed. If suppose there are 2-3 nodes, they wanted to communicate with each other. Okay, they just form a network. The communication between them takes place ad hoc whenever it is needed. Mobile ad hoc network in together. Okay, you can understand it is a wireless network. It is a decentralized one. We'll go through these points, then you'll understand better about this MANET. Then we can go through the properties, characteristics, okay, routing protocols in MANET. MANET are wireless networks which are characterized by dynamic topologies. Okay, we come through this word. What is this dynamic topologies? First, let us understand this topology. Topology is like finding the route. For example, if I want to send data packets from this particular node to this particular node, the process of finding the route between these nodes is like topology. So the finding topology is dynamic here. There are no fixed routes here. Okay? And one more thing that I want to tell, this particular node, if you can take, this can act as a host. It can even act as a router. You can tell how. Let us take an example. This particular node wants to send data. Okay, this wants to send data to this node. So this will act as host. Now this will act as router. The packets will travel through this path. Suppose next time this particular node wants to send data to this node, then this will act as host. What you can observe, a particular node here, this can act as a host, it can act as a router. Each node in MANET is a computer that may be required to act as both host and router, and as much may be required to forward packets. Okay, in order to forward packet, a node may be required to act as a router or else host. MANET is an autonomous collection of mobile users that communicate over relatively bandwidth constraints. There are bandwidth constraints that we will learn in the characteristics as well. Since the nodes are mobile, the network topology may change rapidly and unpredictably over time. The network topology, the routes and all, these things will change with time, because for example, this node can move out of the network, any other node can come, the path between these this can be broken, the packets can be moved from here to here through other route. Okay, because of this we say that network topology may change rapidly and unpredictably over time. The network is decentralized. Let me clear everything, you'll understand better. Okay, now let's start. As I said, this is a centralized architecture, the right side one. Here there is an administrator to guide the network. Okay, this one is decentralized. The network is decentralized, where all network activity, including discovering the topology and delivering messages, must be executed by the nodes itself. In total, if you want to tell something about this MANET, in conclusion, you can tell like A mobile ad hoc network is a collection of wireless nodes that can dynamic setup anywhere, anytime without using pre-existing fixed network infrastructure. There is no fixed infrastructure. These nodes can be set up in any manner. They can start communicating in any manner. They can act as a host. They have the whole responsibility. There is no centralization. Okay. Now let us look at the MANET characteristics. I think you have got a brief idea what MANET is. The characteristics would be simple. MANET, dynamic network topology. As I said, topology is dynamic. The routes are dynamic. Limited security. Why it is limited security? Suppose this node can go out, any other node can come in. That particular node, when entering into this network, maybe it is from outside network, it has been sent with an intention. It may observe the nodes, it may observe the packets data which is being communicated within the nodes. Okay, these terminals are lightweight terminals, autonomous terminal. Okay, the operations, like these are distributed. Okay, distributed operation, there is no centralization. Okay, the nodes, as I said, they have bandwidth constraints. Here, bandwidth constraints, energy constraint nodes, multi-hop communication. This point you'll understand better when we go to the next lectures. In coming lectures, we'll be dealing with MANET routing protocols, where you'll understand this multi-hop communication. Suppose this packet, this particular node want to send packets. Okay, it has to send these packets to here, from then here, like it is basically multi-hop communication. You'll understand it better in the coming lectures. Then coming to the properties, what I would suggest is that you got a basic idea of what MANET is. Properties are simple. These are like just an extension to what we have discussed here. You can just go through these properties. Like, however, these notes will be available in the description. You can just download this, go through these properties. These are very simple. We will discuss the next parts of this topic, because going through each and every line would make this video very long. I wanted to put it short and sweet. Okay. Some of the fundamental differences between the wired networks and ad hoc networks. Okay, now we will go through the differences between the wired networks and ad hoc networks. Ad hoc networks, we have seen MANET. Okay, it is an ad hoc network. Asymmetric links, first difference. The wired networks, they rely upon symmetric links, whereas ad hoc networks, asymmetric links. Next, redundant links. In wired networks, some redundancy is present to survive link failures. Okay, in wired networks, there are some extra links. Okay, those are kept as a backup. Those are all controlled by network administrator. Whereas in ad hoc networks, nobody controls the redundancy, right? In many redundant links, up to extreme of a complete mesh topology. So redundant links, you can note the difference between there and here. There, administrator is there to control these redundant links. Here, there is no person to control that one. Interference. In wired network, links exist only where a wire exists. Okay, suppose communication wants to take place between two nodes, there will be some wire. Okay, communication will take place. There is no other interference. Whereas in the wireless ad hoc networks, any other node can come in. Okay, the nodes can leave. They may interfere when other nodes are communicating. But in ad hoc networks, links come and go depending upon transmission characteristics. Okay, you understand the interference point. Next, dynamic topology. As I said, the routes, we have to find these routes dynamically. There is no fixed architecture here. Okay, I think you have noticed the difference between wired architecture and these ad hoc networks. Now we will go through the applications of MANET. Say there is some different kind of architecture, right? We have wired one, we have now wireless ad hoc networks. So these networks will be having some applications, right? We will go through that applications right now. Military battlefield. Okay, in military battlefield, soldiers wanted to communicate. Okay, those communications all happen through MANET networks. If you take sensor networks, this means it wanted to take some information through sensors. Okay, that thing happens through MANET. Like, let us take the other one, local notebooks, computers, or palm. What is this? Palm top computers. Okay, suppose in a small room, some kind of meeting is going on or some conference is going on, between all those things communication has to take place, because everyone is having their laptops. Now the host wants to send some links, he wants to send some documents to the students. So the communication that is taking place between the students who are present in that conference and the host, that takes place through MANET networks. Next, personal area network. Suppose you wanted to share your information from your mobile to laptop, or else you wanted to share your screen from your laptop to your TV. All these kinds of communication, data transfer, all this takes place through MANET. The other important application is VANET. In the upcoming lecture, we are going to see the differentiation between MANET and VANET. VANET is like vehicular ad hoc network. The communication that is taking place between a vehicle and vehicle, V to V, or the communication that is happening between vehicle and the infrastructure which is present at the roads, vehicle to infrastructure, V to I, all those things we are going to study in the upcoming lectures. Next, civilian environments, like we have seen military battlefield, now civilian environments, like the communication taking place in meeting rooms, sports stadiums, all those things. Next, emergency operation. In case of any fire or flood situations, rescue teams communicate through MANET networks. Okay, there won't be a ready-made infrastructure available. Okay, you have to build up a network, right? In those situations, there won't be fixed network available. The rescue team has to build up a network, though all these communications takes place through MANET networks. So you understood one point. In a MANET network, a particular node can come in or it can go out. Suppose a node left, the path between the source and the destination is broken. Now what about the routing? How packets will be transformed from the source to the destination? That concept, which is called routing in MANETs, that we are going to look now. There are different types of routing that we also look. There are three types, like routing table based, proactive, reactive. Those all things we will look now. Just first understand the basic introduction of routing in MANETs. Routing in mobile ad hoc network is an important issue, as these networks do not have fixed infrastructure, right? This is the main issue. And routing requires distribution and cooperation. MANET provide point-to-point routing like internet routing. Okay, they also provide point-to-point routing same as the internet routing, but there are few differences that we have to notice. The major difference between the routing in MANET and regular internet is route discover mechanism. There is one more difference which is of IP. We will see in the next points. One of the major difference is that route discovery mechanism. What is this route discovery? Suppose in order to transfer data packets from source to destination, you have to find a route, right? Because this is a dynamic topology, you have to find a route. That discovering the process, discovering that route is route discovery. Internet routing protocols such as RIP, OSPF have relatively long coverage times. Okay, but these are not suitable for ad hoc networks. However, MANET has rapidly topology change due to node mobility, making the traditional internet routing protocols inappropriate. That means these protocols which are used for internet routing, those are not suitable for this. MANET specific routing protocols have been proposed. So in order to communicate in MANET networks, there are some specialized protocols that we will study in the next lecture. I said one difference, that is route discovery mechanism. Another difference is that in internet routing, suppose if you wanted to target a particular node, that node will have IP address. That IP address will be having some hierarchy. It will be first having a network ID and a computer ID. Like it will be like some numbers dot other numbers dot other numbers. But in MANET, the nodes having a simple ID. Okay, this is the other difference that you have to notice compared to the internet routing. Now we will look at the types of MANET routing. Okay, these are basically classified into three types. First one is these are based on routing tables. Again, two types: shortest distance algorithm, link state algorithm that use distance information. So in this kind of routing algorithms, the table, okay, the routing table contains the information, routing information with respect to distance. whereas this contains with respect to states. That means nearby, suppose if you want to like this is the source, this is the destination, you wanted to transfer data packets, you have to first send it to some F, some B, then D. This is link state algorithms, something like that, you can understand. Next, the routing stage, based on when routing tables are built, based on information which is built in the routing tables, based on when routing tables are built, there are again three types in this. First one is proactive algorithms. I think I have made a mistake here. I said there are three types. You can suppose only two types based on what kind of information is present in the routing tables when the routing table is fed with the information. Okay, proactive algorithms, reactive algorithms, and hybrid algorithms. Okay, proactive algorithms maintain routes to destination even if it is not needed. That means in the whole network there are so many routes. From a particular point you can travel to different points. Okay, all those routes are maintained prior to the communication. Example of such is DSDB. Okay, we are going to learn this. Always maintain routes, whether communication is happening or not, routes will be maintained. Consume bandwidth, maintain routes which may never be used. Okay, there are some routes which are maintained, the communication doesn't happen, but still from yes, a particular point is there, Z, a route is maintained, but communication never happens. There are some advantages, disadvantages, you can go through this. Then reactive algorithms. Reactive algorithms are like whenever route is required. For example, you wanted to transfer data packets from one point to the other point. Now you need a requirement. Then only the route will be found. Maintain routes to destination only when they are needed. Okay, this is a major difference, you can understand. Proactive, reactive. Here the routes are already founded. Okay, all routes are present in the routing table. Whenever you want to send, you can check the routing table, you can send. Whereas reactive, whenever you want to send data packet, only at that time routes are founded. This one is the example that we are going to look in the upcoming lectures, and also this one. DSR and AODV, dynamic source routing, ad hoc demand distance vector. Next is the hybrid. The combination of these both protocols is the hybrid protocol. Okay, in this we are going to look at zone routing protocol. Okay, all right, then we will meet in the next lecture. We'll go through these four algorithms. After that, we'll also go through the challenges. Then we'll go through the VANET. Then comparison between VANET and MANET.